Hi guys, good day, welcome back to my channel. This is me again, Justine, an electrical engineering student. Today I will make an overview of module number 7. So if you're interested, please keep on watching. Now let's start. Introduction to IC packaging. Foundries, the big semiconductors manufacture the silicon wafer turned into IC and dies. Main foundries are TSMC, Global Foundries, and UMC. Next, the fabless. Design and market the chips, smaller companies. Example are Nvidia, Qualcomm, and many more. So, what is the difference between the foundry and the fabless? The fabless company concentrates on the research and development of an IC product, while the foundry concentrates on manufacturing and testing the physical product. The outsourced assembly and test company, it is for the packaging and services, while the IDMs or the integrated service device manufacturer, full vertical integrated design, manufacture, and package. Example are the Intel, IBM, Texas Instruments. Single die packaging. 1970s traditional form of packaging included a single die into a package. PGA, BGA, DIP, QFPS. When more functionality in a smaller space was needed, of SOC appeared. So, analog circuit, digital circuit, and optical circuits. Multi-die packaging, we have the system on chip, complete system on one chip, the multi-chip module or the MCM, interconnects component, and we have the system in package or SIP, stacks chips or packages, and lastly we have the system on package or SOP, optimizes the BTW chip or package. So next, we have here the timeline. So in 1970s, we have the dual inline package or the DIP. Next, the quad flat package or the QRF. Next is the SOP or the small outline package. Next, the LCC, the leadless chip carrier. Next, the PGA or the pin grid array. And lastly, we have the BGA or the ball grid array. 3D packaging versus the 2.5D. The 3D packaging stack groups dies performing the same function, vertical and horizontal integration in package. The 2.5 packaging integrates several electronic devices inside a single package by assembling them side by side on a shared base. The base and interposer provides connectivity. So the interconnection techniques, we have the wire band, interconnection between die and packaging using wires, most cost-effective and flexible, very reliable, low cost, and requires more space. The flip chip connects semiconductor devices to board using solder bumps deposited on pads, smaller chip and shorter interconnection, medium cost, and requires less space. Interposer, layer between the subtract and the dice, high cost but requires the least space and it is better in performance. So the system and package, the origin is the first used the term SIP was January 2000. What is the system and package? Group of ICs mounted on a common substrate can contain passive component embedded in the substrate. So the application of SIP technology used for 2.5 and 3D packaging, high demand of SIP for small devices, for example, the wearables or health, automotives, Internet of Things, and artificial intelligence. So the component of SIP interconnection is the flip chip technology and the interposer layer. So that is for today. Thank you so much and have a great day, everyone.